And then, yay. All right, so welcome everybody to our Govys for April. And we're very happy to have Erica Tiagi. Am I saying your name right?
Yep.
Okay, perfect. From the Urban Institute with us today. And she was very kind and gracious to come back again after an eventful March our Govys meeting where we had some unfortunate visitors. But anyway, so we're glad and happy that she is willing to be here today. So without further ado, I will turn it over to Erica. And as usual, Erica, we're pretty informal, and so I don't do a huge introduction. So if you would be so kind as to introduce yourself, that would be fantastic. And the floor is yours. So I guess so this is a webinar. So I guess people should put questions in the Q&A. We have a Q&A, right?
Yes, there's a Q&A and then there's the chat. So I think both are available. So either way.
Either one works. So, all right, perfect. So Erica, thank you so much for being here today, and I'll let you take over.
Sounds good. I actually just tried opening the Q&A and lost my screen share, so I'm gonna redo that really quickly.
Yeah, thanks. And I have the actual chat open too, so I can track the chat.
Sounds good. All right. Keeps telling me that I have to resume my share. Off to a bad start.
No worries. It looks like it's starting. It's telling me that it's starting, but
yeah, I just can't see my own screen. Let me try one more time. Okay, there we go.
Yep, we can see it now.
Cool. Thank you, Wendy and Donna. So as mentioned, my name's Erica, and I'm a lead data engineer at the Urban Institute. And for folks who don't know, the Urban Institute is a nonprofit also based in DC that's full of a bunch of economists and researchers and folks aiming to elevate the debate is their tagline, the bottom left. They basically just produce research, data, and evidence to help advance upward mobility and equity. So I specifically sit on the research technology team within the Urban Institute, which means that I, along with other data engineers, software engineers, web developers, and data scientists, basically aim to produce tools and systems, and also just improve or support the work of researchers trying to do more quantitatively rigorous work or trying to use new technologies or new tools. So my work is very largely aimed in the space of trying to use technology to support policy researchers. So the talk that I'm excited to share today is based on a blog I wrote, I guess a couple months ago now, aiming to talk about how the Urban Institute has integrated R with serverless cloud computing. And I'll talk a lot more about what serverless cloud computing means, because I'm assuming a lot of folks here know a lot about R and maybe a little bit less about the cloud computing piece of it. So just for a bit of motivation about why I was specifically interested in this topic, the first thing is just we really want to bridge the gap between two separate technologies that had just led to a lot of innovation at Urban over the last 4 or 5 years. So one is R, and again, I'm not going to go into the weeds of how that's worked, but it's been a lot of folks building iterated fact sheets or shiny dashboards or fiscal briefs or other kinds of basically just using R to replace what had either previously been done manually in Excel or replacing, Stata or SAS code with R code and just leveraging some of the tools that R makes easier, or some of the things that R makes easier to do there. So there's been a lot of innovation in the R space. And then sort of in a separate silo, there's been a lot of innovation from AWS Lambda, which is basically just a system. I'll talk more about what that means, but it's basically just a way to build applications or build servers or build services that run within the cloud. So again, sort of two different things where when I think about the tools or projects that Urban has produced on the research technology front over the last 4 or 5 years, almost all of them have either used R or used Lambda, and virtually none of them have used both R and Lambda. So I'm specifically interested in trying to bridge that gap a little bit more. And then the second piece that really relates is I really want to make Lambda and serverless computing more accessible to researchers and data scientists. The main reason why there's been these sort of two different silos between R and Lambda, that Lambda has mostly been used by software developers or data engineers or people who aren't necessarily researchers or data scientists, and it's sort of been seen as like, if you want to use this tool, you'd have to write code in Python or you have to use JavaScript. It's basically been like a R can't do this or R can't be used in Lambda. So that's specifically what motivated me to dive into this a little bit more and then try to build up Urban's internal tooling around being able to integrate R with Lambda. So in terms of what I want to talk about today, 3 questions. The first is, what is Lambda and how is it useful? I'm going to spend a good amount of time on this just because I think it's hard to think about what AWS or cloud services mean, especially to folks who don't have a lot of experience with previous cloud computing. So that's the first thing that I want to cover. The second is really dive into the weeds of step-by-step. Here's how you run R from Lambda. I'm going to walk through 2 different approaches for doing so, where I think there are pros and cons to both of them. And then the third thing is I really want to focus on specific use cases, specific use case in terms of how folks at the Urban Institute have integrated this, which hopefully will be relevant to other folks here. So the first thing that I want to talk about is, what is AWS Lambda? So at the most basic level, it's a service from Amazon Web Services, although other cloud providers have similar kinds of, they call them Azure functions or GCP functions. And the gist of it is that lets you run code in the cloud without having to manage servers. And for a lot of maybe folks who are data scientists or analysts, you don't really manage servers anyway, so that's not directly relevant. But the basic way to think about this is if you want to take like some kind of a small piece of code and then you want to run it maybe every day or every month or on a regular cadence, or maybe when something else happens, maybe when someone sends you a file, you want to do something to it in response to that. That's sort of the space that AWS Lambda lives in. It's not so much suited for things like I want to, run big data or I want to run machine learning models, although people use it for some of that. But it's really meant for that sort of, I want to run like small chunks of code or I want to run small jobs without having to think about building or think about working with maybe like a DevOps team or like a security or infrastructure team. I basically just want to run something not on my computer, but in the cloud, and then have all of that be automated. So again, I realize this is a little bit abstract. So this morning I asked GitHub Copilot, Urban's running generative AI pilots right now, to help me come up with a little analogy. And I really like this one. I think it's actually pretty useful. So the way it suggested explaining Lambda to folks who don't have cloud computing skill or backgrounds are that you can think of it like a kitchen in a restaurant, where in this case, you're the chef and you only care about preparing the food. Although in this case, you only care about writing code, and you don't want to have to worry about what they describe as maintaining the kitchen, cleaning the kitchen, or turning on an oven, which for folks in DC, it's pretty hot today, so I also don't want to turn on an oven. The idea here is that you are the chef, and then Lambda is the kitchen staff within this restaurant. So Lambda is like the service in this case that takes care of maintaining the kitchen, cleaning the kitchen, turning on the oven. In the Lambda case, a little bit more, they take care of security for the servers, they take care of managing permissions, they take care of patching, they take care of provisioning the servers and figuring out how big they should be. So again, less about the oven and a little bit more about managing the underlying infrastructure and managing the servers. So then in terms of how those interplay is that you as a data scientist or analyst are just responsible for providing the recipe or the code. Lambda takes care of executing it whenever, in this case, some specific event happens, or if a customer orders a dish, going back to the analogy. So hopefully that makes at least a little bit more clear or more confusing, one or the other, depending on how your brain works. The basic idea here is that you're responsible for writing the code, and then Lambda, this AWS service that's managed by Amazon, they're responsible for running that code when a specific thing happens to say, hey, I want to run the code in response to this event. Appreciate the positivity towards the analogy. So just for a little bit of terminology, and again, this should hopefully be clear by the last couple slides, but I think there's just a lot of jargon that comes into play when you first start working with AWS services. So Lambda is referred to as a serverless cloud computing service. In this case, serverless doesn't mean there isn't a server. It just means that there still is a server, but it's abstracted away from you. So Amazon's the one who's responsible for managing that server. So sort of like from your point of view as the developer, as the data scientist or analyst, there isn't a server because you can't directly access it. You don't have to worry about it. So you'll hear serverless cloud computing tossed around a lot in this space, and that's just what that means, is that the cloud provider is responsible for managing and provisioning that server. So it's serverless to you. And then a couple other pieces of terminology that you'll hear a lot is that you define what's called a Lambda function. So it's basically just saying this is like the code that I'm writing, whether it's Python code or R code in this case. You package that into what's called a function. So it could be the equivalent of like an R function, but it's effectively, but it can also be a lot of different functions, or just like one with wrapper around it. So people talk about Lambda functions, and that's like the unit of a Lambda. But just note that it doesn't have to be a single R function, or a single Python function, or a single whatever function. And then that code is run in an environment when triggered by what's called an invocation event, which can be, I think there's like 200 some different things it could be, but it could be anything from I want something to run every day at 8 a.m. or I want something to run on the first Tuesday of every month. So it can be maybe time-based, or it can be in response to, hey, someone visited this website and I want to run this Lambda function based on something they did. So it can be something like an API or like a web application, or it can be something like, I got a new data file and I want to run a new summary statistic, or I want to run summary tables based on that. So again, there can be any sort of event, but the idea behind Lambda is that you only pay for what you use. So if you don't have any events coming in, if there aren't those maybe new data files, or if there aren't any hits on your website, no one's going to your website, then you're not going to pay for just sort of idle time like you would with traditional servers. Instead, you're only going to pay for the time that you're actually running the code. So I'm going to pause there and see if folks have any questions that I'm actually not sure if folks can unmute, but if you want to put questions in the chat about specifically on like the what is Lambda. I'll talk about use cases in a second too.
Yeah, thanks. If you have any questions, yeah, put them in the chat or the Q&A. Yeah, I like the kitchen analogy too.
Mm-hmm. Definitely made me a little hungry doing that around lunchtime today, but hopefully it's helpful.
That's very true.
Mm-hmm.
And you said ChatGPT or one of the generative AIs came up with that analogy?
Indeed.
That was pretty cute.
Mm-hmm.
All right, I don't see any questions.
Sounds good. I think this is pretty clear based on what I mentioned before, but just to flesh out a bunch of common use cases, they tend to fall either into like the data processing categories. That can be things like building data pipelines or running QC checks, or validating data or making simple transformations. Things like APIs or web applications. So a lot of that, someone goes to a website and then you do something in response to that. And then where we use it a lot is around scheduling tasks or monitoring or alerting. We recently had this week, someone was sending out a bunch of automated emails about acceptances or rejections to a conference they were running, and we sent a bunch of automated emails with Lambda. So really just like a lot of sort of that like scheduled automation. I want things to run in a particular way. I don't want to have to either run it from my computer, or I just want to have that be one fewer thing that's on my plate, are a lot of the use cases that we see a lot. And I'm just going to take a quick second to highlight a couple that I think are really helpful and also have very tangible R components. So one is, and I pulled them up a second ago, and these are based on examples that Urban and I have worked on. One is the education data portal, which is basically just a big open data portal for all the major data sets released by federal agencies on school district or college level data. So basically just like a programmatic way to access this data and have it harmonized over time and across data sets. So we offer something that I think is really cool and kind of underused called the summary endpoints, where basically for each of these data sets, if you want to compute, suppose you want to compute the average student enrollment by something like CBSA or FIPS code or something, then through this R package that we built that basically calls a Lambda function on the back end, then you can get really quick, like this will take maybe 10 or 15 seconds to run, data that's running across, in this case, would be like hundreds of millions of rows because it's using that Lambda backend. So instead of having to pull individual data files from all the different websites, aggregate them, and then run this summary, run this, in this case, average. So I guess like run this average across the groups or across CBSAs, then this is just the way to leverage Lambda and leverage that serverless infrastructure to compute aggregated summary statistics really, really quickly. And again, there's an R package I feel obligated to highlight, but I'm not going to run it right now. But again, this is just an example of like a way that we've been using Lambda that's been really successful for us. And one more quick example comes from our spatial equity data tool, where the basic idea here is that users can either use sample data sets or upload their own data sets. And then so here I'm going to use a data set on public libraries in the United States. And then once I click this run analysis button, right now there's a Lambda function running in the background that's basically computing for all the public libraries in the US, what demographic groups are over and underrepresented. So here you can see that white non-Latinx groups are overrepresented in terms of where libraries are, and cost burden of rental households are underrepresented. But again, everything that happened in the background to produce this graph and produce this map here is just a Lambda function on the back end. So there's just a couple of ways to hopefully make a little bit more tangible of how Urban's been using Lambda functions. And again, these are both, I should note, Python-based. That sort of speaks to what I mentioned at the beginning of, we've seen a lot of really cool applications, a lot of really cool tools written in non-R on that innovation front, and just realizing how many people have really good ideas, have existing code bases that would be good fits for Lambda. But again, there are programmers. So just figuring out how to make sort of that R ecosystem more amenable to Lambda.
Hey, Erica, there's a question. I'm going to interrupt you if that's okay.
Mm-hmm.
It's in the Q&A. In the education example, does the R package pull the data and process it? Or is that what the Lambda function is doing?
Yeah, that's what the Lambda function is doing. So the R package is basically just calling an API endpoint. So then the Python code is a good way to get this. But the R package is basically just going to this URL right here. So it's basically just parsing the code, parsing this into the format for the URL. And then the Lambda function is what's responsible for actually pulling the data and then processing it. I'm happy to answer more technical questions about how the backend works. We basically just take all of the data and then convert it from its original CSV formats into what's called a Parquet format, and then store that, which is more efficient because it's columnar based. So instead of storing data where each row is a unique observation, we store it in terms of columns, which just means that if you only need 1 or 2 columns from the data set, you don't have to read all of those rows. And that's basically what lets us pull the data really, really quickly. That's sort of the gist. The Lambda function is sort of the workhorse here, and then all the R package is doing is converting this into like this right here into a URL.
Thank you. So is this portal available publicly?
Mm-hmm. Yeah, we would love for more folks to be using it. And I'm happy to put the links to both of these in the chat too.
Yeah, thanks. So I'm thinking of cost. So because it costs money for Urban to use the AWS Lambda, right?
Yeah, so what's really great is I actually am like the lead engineer on this particular project, and we get like maybe a couple thousand summary endpoints requests per month, and we currently pay $0 for that because, and I'll get to this a little bit later, but Lambda has a really generous free tier, which basically means that you can get 1 million requests per, a little caveat there, per month for free. So again, until we start getting 1 million people requesting, or 1 million requests per month, we're not paying anything to maintain that infrastructure, which is really, really great from a cost benefit. And then even after that, you can see there's 1, 2, 3, 4 zeros here, and then 20 cents per million. So we are technically bearing the cost, but in terms of what it ends up being for us, it's super, super cheap, which is really nice.
Wow, that's amazing.
Mhm.
All right, great, thanks. I'm glad I asked that question because I was wondering about the cost of all this. Wow,
Mhm.
okay.
Yeah, and I'm going to
Oh,
respond to the
I'm
other part of the question. So the specific benefit for the summary endpoints is that if you think about in this case, what it's averaging over is this is every single K through 12 school, of which there's, I don't know, tens of thousands maybe. I should probably know the answer to that question off the top of my head. Times in this case, it would be 1986 to 2022. So, and then we also want this data to be disaggregated by suppose you want this data to be disaggregated by grade and race, then what you end up having is just data sets where you're pulling hundreds of millions of rows. And depending on like sort of which set of information you're looking or which set of breakdowns or set of aggregations you get, you could easily end up into like the billions of rows. And again, it's totally possible to do that in R. It's just going to be really slow and it's going to take basically just like a lot, like several minutes, if not hours, if not a little bit longer, or your computer is going to crash or our studio is going to crash in order to get that. So the basic idea here is that by having the Lambda function process that data more efficiently for you, then it just means that something that would otherwise require you to first download all of that disaggregated data and then compute that group by summarize or filter group by summarize R code, then and that would basically just like be really memory intensive and also time intensive. Then Lambda, by virtue of having that infrastructure do it for you, can just give you that data within a couple of seconds. And you only get the summary row instead of having a summary table without having to first download all of that disaggregated data. Does that make sense? Or is that helpful?
Yep, yeah, they said it makes sense. And then you said the result is a URL. So I suppose then once we have the result, then we click on the URL and then we have the summary or the data or whatever.
Yeah, I can actually just open up our studio for this. In this case, it's actually going to the R package is just going to return a data frame for you. So the R package basically just makes this easier to, if you think about something like tidy census, which maybe is going to be a helpful comparison, as opposed to getting that data as like a JSON, which is what the census API would report. In the same way, instead of getting that data as a JSON from the API for the education data portal, you would just get it as a data frame.
That's good. Okay, perfect.
Mm-hmm. I was a little nervous by live demos, but
Thank you.
mm-hmm. I'll give it a couple of seconds. Maybe we'll just leave and come back and see if it, yeah.
It's pretty cool that you have Stata and Python and R there.
Yeah, this was very much originally developed for researchers. So we really wanted to, we also have a Stata package. So really, as much as a lot of us were like, what if we just use R? What if we just use R and Python? I think we realized that we just ended up, we're going to have a lot of Stata users. So doing anything to make it easier for them was maybe a little bit antithetical to our open source love and preferences, but we thought it'd be useful.
Yeah, it's always better to be inclusive, right?
Mm-hmm. Okay, so going back to, and it's the same thing here, where Lambda and the workforce doing that calculation. So I do also want to emphasize that these are just a couple that I wanted to pull out, and also a couple that have R packages. I should mention there's also an R package here that was released, I think, last month, which is exciting. But we really just have been using Lambda in a lot of different ways. I just want to highlight a couple here. Just a lot of text, but I also did a quick Google search, and there's a fun white paper from a couple of years ago that highlighted examples of how government agencies have been using Lambda. And here's one from the NSF, where they were acquiring and provisioning scientific bibliometric data on a weekly basis. So sort of fitting into that like automation camp that I mentioned, the automation scheduling kind of tasks that I mentioned earlier. And then they use Lambda to reduce O&M overheads and allow on-demand execution of data pulls. So again, this is just one example, but I think it is something that you are seeing a lot of government agencies using more of over time. That's a good question on the well, it's also saying the question in the Q&A about whether Urban's hosting all of the education data, and if so, how much work is that for Urban IT folks? I would say that the answer is very much that by virtue of using a serverless architecture for most of it, it's really not that much work for IT folks. And I'm simultaneously a developer and also probably the main person who does that IT. So we don't have designated DBAs or other kinds of IT or security folks who are intimately involved in the project. We do have like general processes for how we manage databases, how we manage servers, how we manage cloud resources. But it really hasn't been a lot of work to maintain. Like I think the most time-consuming part of the education data portal really has just been we're integrating data from 40 different sources that each have their own release schedules and that each, report data slightly differently every quarter, every year. So really where most of the time and resources for the education data portal comes into play is really around just like cleaning and harmonizing the data as opposed to maintaining the portal infrastructure itself. Let me know if that doesn't answer the question about how much work maintaining the education data portal is. But yeah, Urban is hosting all the infrastructure for it. All right. So back to Lambda. I also recently gave a talk specifically on the education data portal. So I also have a version of that if that's more interesting to folks too. But going back to Lambda for a second, hopefully this is clear by what I've mentioned earlier, but I think the 4 sort of breakdowns of reasons why I think it's so useful is one, is that's highly cost effective. We can again support those thousands of summary endpoint requests per month for free in our case, but effectively for really cheap, just because we're only paying for the time when users are actually making requests. So again, right now, if we don't have any users making requests, we're paying $0. And people often talk about how it scales to 0 being the phrasing there. Basically saying if no one's actually using it, if it's not being used, then you're not paying for it. So that's the bulk of why it's so cost effective. And also just the fact that I don't have to deal, or I or others at within Urban's IT department don't have to deal with provisioning the servers, doing patches, thinking about backups, managing the security. The fact that all of that is managed by AWS also just means that's cheaper from like a labor perspective, and that just in terms of ongoing maintenance costs, because again, I only have to focus on my code, and then I'm effectively asking Amazon, by virtue of paying Amazon for the service, to take care of all of the provisioning, managing of servers. And then another thing that's really great is just how scalable it is. I don't remember the exact numbers, but I recently looked this up for a project. So the basic idea is that whether I have one request or if I have thousands of requests, I don't have to think about paying for a bigger server, or paying for a bigger database, or refactoring my code to accommodate just the fact that I have this increased demand. Amazon does that for you, and AWS does that for you by virtue of just running more Lambda functions concurrently at the same time. So again, if you build a website, you don't always know whether you're going to get one user who's really enthusiastic, or if you're going to get tens of thousands or millions of users. So by virtue of using something like Lambda or something like a serverless backend, that effectively means that you don't have to necessarily predict how much or how resource intensive or how much traffic you're going to get, and plan your infrastructure accordingly. All of that scaling is done automatically. There's also just been a lot of folks who are really enthusiastic about developing the serverless Lambda community. So I think there are a handful of like AWS services that just exist for a couple of years, and then they don't get a lot of traction, and then they end up just like dying a couple of years later. I think what's great about Lambda is that folks have just found a lot of use cases. So there's just a lot of investment, both from Amazon, but also from the broader open source developer community, to making it work for more use cases, basically creating extensions and resources. So I just have found that it's like it's a space that I think has a lot of invested people making it better. It's kind of like R, I think. Where I think integrating R with Lambda is an example of how it's sort of improved, or how it's been able to scale and be flexible to accommodate different use cases. So So now sort of getting into the meat of why me wanting to figure out how to integrate R with Lambda first place is relevant. There are a couple of key limitations. The first one is just that each function can only run for 15 minutes. So again, this really isn't meant for sort of that like massive job that's going to take hours. It's really meant for sort of these like short kinds of things that just want to quickly compute summary statistics across data, or I want to compute disparity scores across a geographic data set, or I want to send a bunch of emails at 8 o'clock in the morning in an automated way. And so it's really meant for those kinds of short running jobs because it has this maximum 15-minute runtime. There are a bunch of infrastructure constraints around like how much memory, how much storage, but if you're running into these, Lambda is probably not the right tool for what you're looking for. Then the most important thing for this talk is that it only natively supports these programming languages, notably of which R is not one of them. So this is really the crux of why for the longest time, Lambda and R just exist in isolation, is because there just wasn't a way to natively or really at all run R from Lambda, which basically just meant that folks either had to ask their friend who knows Python or ask their colleague who knows Python to convert their R code into Python code, which just naturally adds friction between teams, or they had to just altogether rewrite a code base from R to Python, or they just altogether were like, well, Lambda can't work for me. So again, this like last point just around like Lambda doesn't natively support R is the crux of why sort of that dichotomy and that disconnect existed. So this is the talk about how you can run R from Lambda. So the basic idea is that in, I think, December of 2020, AWS released what are called custom runtimes through container images for R. And for folks who maybe are familiar with Docker or other kinds of container services, hopefully this should be familiar. Hopefully some of the concepts should click. The basic idea is that you want to create a container or just a way to package all of the software and all of the dependencies needed to run something, needed to like run code in a single thing, which is what the container is. So Docker is basically a service, so it makes it easier to do that. So in that container image is effectively just like packaging your code and your dependencies all together. And then the two different ways that I have found to run R from Lambda are using RPy2, which is basically just, I don't know if folks are familiar with Reticulate, which is basically a way to run Python from R, but RPy2 is the opposite of that, where it's basically a Python package lets you run R from Python. So it's sort of like cheating, where basically I'm saying I'm going to use that Python runtime and then run R from it, is the RPy2 approach. So that's option one. And then option two is using the Lambda package, which I'm not actually sure if that's how you pronounce it, but I think it's a contender for cutest hex sticker, if nothing else. That's basically just a package that someone wrote and maintained, or wrote and then mostly maintains to make some of this a little bit easier. So again, two different approaches. One is a Python package that lets you run R, and that's RPy2. And the second is an R package that takes care of some of the overhead of like creating R runtimes for Lambda. So I'm going to walk through how to use both of these, two options. But any questions so far before I get into the weeds of how these work?
I don't see any questions, but did you write the Lambda R?
No, I did not. I forgot the name of the person. I should note that they're definitely not the first person by any means to try to do this idea of like running R from Python. There have been a handful of folks who have tried different ways of doing so. I do really like this package, and I do think that there are a lot of cases where it is useful, but maybe a future R Govys talk can feature the author of the package.
That challenge accepted. Okay. And I love the hex sticker there.
Yeah, I think Purr is the only cuter hex sticker I've ever come across, but I do really, really love the little add-on.
Great, thank you.
All right. Seeing no questions. So again, the basic idea for both options, whether you're doing option one or option two, is that you define what's called a custom runtime through that Docker container image. that has R installed. So by default, the Lambda runtimes aren't going to have R. They're going to have Python or JavaScript or any of the other languages. So you basically need to create a custom version of that. So you're going to use what's called a Docker file, which is basically just like a template or like a blueprint for creating that container image. You're going to upload that container to AWS using what's called ECR, which is an Elastic Container Registry. I think that's what it stands for. It's basically just a registry that Amazon manages to host a bunch of different containers. Step 3 is the R part where you write your code. And then step 4 is just where you deploy that Lambda function using the container image. So these steps 1, 2, and 4 are the only like quote unquote new steps, and all of them are fairly templated. It takes a second or two. It's really just like a couple lines of code. I have a demo repository that I put together that really should give you 99% of the way. So basically the idea is just that automating steps 1, 2, and 4, so those are like the AWS steps, it really lets you just focus on 3 of like writing your own code and not having to think about what is Docker, what is a container image, what does ECR stand for. But sort of these are just like the key steps you're going to need to think about when running through this option.
Can I ask a question?
Mm-hmm.
So best practices for doing this. So I'm assuming when we write the code, we should, make sure it works on our, laptop or our studio or whatever. And, and then go from there. Is that I guess that would be the best, maybe the only approach. But can you talk about that a little bit? In terms of writing code and developing it and then having it run on AWS with Lambda?
Yeah, definitely. That's exactly right. But I think where it's most useful is either you already have code or you're developing code that runs locally, does something what you want locally, and you just want to have it be run on a regular basis or run in response. So I think all of the general best practices around like version control and documenting your code and using things like automated tests still apply to Lambda. I think something else we've seen a lot of is, though they mentioned at the very beginning, Lambda assumes that you have some kind of an invocation event or something to trigger the function. So making sure that you have good example tests of here's what I expect that input to look like. Here's what I expect the like input to like the event that will trigger the Lambda, making sure you have good tests there apply. But the general like our workflow is exactly what you mentioned. It just write code, test it locally, and then if you want, you could do something like when I push my code to GitHub, then I want to automatically run these tests and also deploy to Lambda. So a lot of like the sort of like engineering development best practices around like how to test and deploy and maintain version control apply. But yeah, everything should be done just like within a conventional RStudio environment. So hopefully not a lot of like new things being introduced. Is that helpful or is that?
Yeah, yes, because I guess I'm a little bit old school and I'll be dating myself, but because, really the cloud computing, I mean, I know it's different, but it still reminds me of, back in the day when, things were done on the server somewhere and you just had like a thin client or something or, okay, now I'm really dating myself, or maybe I had punch cards and I, had my program and then it got submitted and it ran overnight and then I'd come back the next day and I'd have errors and then have to fix it and then send it off somewhere to try it again. So you wouldn't do that, I would suspect. That it would not be good programming to say, oh, I'm going to write some R code, send it to the AWS, run it, see what fails or whatever, and then do it that way. So you would do all the development, debugging, those types of things locally.
Yeah, exactly. And workflow that we found works a lot is for basically like someone like me, someone like the engineering team will set up like the AWS components of it within like a GitHub repository. And there'll be like a section where it's like, this is the R code. And I'll build some kind of like a CI/CD or like GitHub Actions continuous integration pipeline where whenever like the analyst or the data scientist uploads their R code to GitHub, that automatically triggers the deploying the new function, and then they can use R or some kind of like a command line to test it if they want to at that point. But basically like the only thing that like the person writing the R code would have to know. It's just like, here's how I push to GitHub, which hopefully folks should be familiar with anyway. So less of like the more conventional or like the more traditional interaction with cloud computing and sort of that more like abstracted away, and a little bit more just like I push something to GitHub and then it gets deployed to the cloud.
Thank you.
Any other questions about sort of the big picture here?
I don't see any.
Sounds good. So this is just quickly walking through. I'm not going to get into the weeds because no one wants to see me walk through a Docker file. And these are also linked here, then also in the repository. And the idea is that you should be able to just copy and paste this and not have to think or worry about this. The basic idea is that you create this Docker file here, you install R. So that's what we're doing. So you create this Docker file, and then you start from a Python image. So again, like the details of the syntax aren't super relevant, but the basic idea is here is saying start from an Amazon provided Lambda environment that already has Python installed. Here we're just installing R. So this is like when you go to R and install, like use like go to like, I don't know, RStudio or whatever the website where you install R for the first time is. This is what's doing under the hood of installing a specific version of R and then running all of this stuff. Here you install the specific R packages that you want. So here I'm installing an AWS package that interacts with a storage layer called S3 and then dplyr. And one thing to mention here is that I'm specifically installing from Posit's package manager, which it's just a lot faster, I found, than installing from CRAN. And who doesn't want to spend less time waiting for packages to install? So that's all that's happening here. And then here I'm installing what is going to include the rpy2 Python package. So again, that's that package that lets you run R from Python. So again, details aren't worth getting into. And really, unless you want to update the R environment or unless you want to add more R packages, you shouldn't really have to touch or do anything with this file. It's just sort of like the infrastructure to build that image that has R installed for Lambda. So this is sort of the first step of basically both options, but of option one here. And then here I'm including just really simple R code where there's not a lot of interesting things going on here. It's basically just returning even if the number that's passed into the function is even, odd if it's not. So really not a lot of exciting things happening. And then this is the Python code. So again, this is our code, and this is the Python code where this should look familiar, but here I'm just sourcing, so like loading in this R code that's going to be here within an R script called like utils or utilities. And then I'm just returning what comes out of this function right here. So this is all of the code for the Lambda function or the Lambda handler that's written in Python, where again, all it's doing, and this will run locally too, is just creating an R object, which is what rpy2 gives you. That's basically that binding between R and Python. Running this function, so passing this number that gets pulled from the Lambda event into this function, and then just returning it back. So again, there shouldn't be a lot of the R code is where the bulk of the work should be. And this should be pretty much just like kind of boilerplates where you're basically just saying, replace the name of the function where instead of parity, it'll be whatever you want to call it. But this is the only like Python that needs to exist for this framework to work. Then everything else is just, you should be able to functionally just like pull any arbitrary R code into the R script here. And then it should work with caveats around the R code working and everything else there. So that's sort of the gist of option one. And basically you're just like cheating, taking a shortcut of using rpy2, this package that sort of gives you that binding between R and Python, and then using the fact that Python is already a native runtime, and then everything just like works from there. And this is the approach that I've used the most. I think it's really robust. It works really well. I've used in a lot of different settings. It's also just really easy to maintain, which is nice. Like we have half dozen R programmers who range from people who are really comfortable package developers who have a really particular and really dogmatic ways of programming, to folks who are really new to R. And in both cases, it's worked really well for them because, again, they don't have to think about infrastructure or Python or cloud computing. They can really just focus on their R code. So on this piece and making that as adding whatever they want within there. It just lets them sort of benefit from serverless cloud computing, from Lambda, but again, only having to worry about their R code. So I'll pause there and see if folks have any questions about option 1, which is the RPy2 shortcut approach of taking advantage of the Python native support.
So just to make sure I'm understanding, so the Python code there at the bottom, that would just be repeated, except, or I mean used, except maybe changing parity to whatever your code was called. And so then all the code, the R code could be whatever you need in that upper block.
Yep, exactly.
Good. Okay.
Yeah, if you're someone who doesn't want to learn any Python, great, you don't have to. This basically is just like arbitrary code that should work for anything, replacing the name of the function with whatever you need. So all of like the work, like all of the heavy lifting is done exclusively in R. This is just wrapping that R code in.
Thank you.
And then this is option 2, that again uses the very cute hex code stickered R package called Lambda. I'm going to go with Lambda. So notice the steps are really similar, where again, you create a Docker file, but note that here I'm just starting from a Lambda provided base Docker file, where again, note that earlier I started from a Lambda Docker file that already had Python. So with this approach, there isn't Python or any other language involved. There's just basically just like a blank slate. Here I'm specifying an R version and then the name of the script, where here I'm calling it app.r. One thing that I will note is I really liked the idea of this package working really seamlessly. I ran into issues if I tried updating the R version, and I'm sure I probably could have resolved them if I wanted to, but it just, I spent like half an hour on it and it was kind of tedious. So it does seem like there's a little bit more of like kinks to be worked out with the package. Whereas again, with that RPy2 approach, things just like worked a little more seamlessly around like updating versions of R, doing things like that. But here is where you'd specify the R script. Again, this is the same stuff as before. It's just what's happening under the hood in order to install R. Same thing here, where I'm installing R packages, where notably I have to install the Lambda R package in order to be able to use it, but otherwise you can add whatever other packages you want. And then this is basically just a bootstrap script that just calls the R code itself. So again, details aren't worth getting into, but the important part is that you're running R script, the name of the R script here. But again, in terms of things you'll ever really realistically have to update, it could be if you want to use a more recent R version, if the name of your script changed, or if you want to install more packages. Those are the things you're actually going to have to update. Everything else is basically just like static. It's never going to change. So these are pretty similar. These first 2 steps for option 2 are pretty similar. And then rather than previously, again, remember we had R code and then also Python code, wrapping the R code. Here we just have the R code, so you don't have to write any Python code whatsoever. And then the important part is, so again, this is the same R function, it's just returning even or odd, depending on whether the input number was even or odd. And then you have to include this start Lambda function at the bottom of the R code. And then that is going to do like the heavy lifting of taking care of what was previously taken care of with Python in the other version, or in the other option. So that's basically the gist of how this version works, where it's simpler in that, again, you only have to deal with R, you don't have to deal with Python. And then just by virtue of adding this one line of code, it takes care of all of that, setting up the ability to process the events, listen for events from AWS, and then return it back. So it takes care of all of that like AWS R interface piece. So again, it makes things a little bit simpler, but again, just from personal experience, I found it to be a little bit more finicky of a package where I think it just worked in some cases, it didn't work in others. And then it's also just more limited in that, again, as mentioned at the very beginning, there's just a lot of, there's like 200 some invocation types that Lambda supports. The package, again, I think it's super useful that it exists. I think it's super useful for a lot of use cases. It only supports a handful, I think maybe 1 or 2 of those different invocation types. So depending on what you're using, the package could be a really great way to get started with Lambda. But depending on, your use case and what you're trying to do with it, I think I just ended up running into limitations that made the option 1 of using RPi2 as the bindings work a little bit better. So that's the option 2. Admittedly, I don't know everything about how it works under the hood. I do know that from personal experience, it works really well when it works, and then it didn't work when I tried changing some things. And I also have a lot of respect for people who maintain our packages thanklessly. I'm really glad that this does exist. But any questions about option 2 before I just finish with a few ways that Urban has used this R and Lambda integration?
I don't see any. I'm not really a Python user, but I seem to like the Python approach you have better too.
Yeah, I just think it's more flexible for like whenever we wanted to change something or do something, it just worked a little bit better for us. There's also just a really rich like AWS cloud computing ecosystem around Python. So we could borrow code that already exists, use Python packages that already exist. So sort of being able to use both at the same time. So maybe have a lot of like the research or domain logic in the R part and some of like the AWS integration written in Python, sort of like leveraging the best of both worlds and like the comparative advantages of both languages. It just generally worked better for us, but your mileage might vary, so.
Yeah, no, I think, well, it's good to have options, so, yeah. Thanks.
And then all of that is in a GitHub repository that you should be able to just clone and then get started right away. So I will link to that afterwards. And the very last thing is just I want to highlight a few ways that Urban has used this. And again, there's been others, but these are 2 that I think are particularly exciting. One is just to automate data collection. So as I'm sure folks here know, there's lots of different government agencies that release data, sometimes on very strict schedules, sometimes less strict of a schedule. So there are a handful of folks in our NCCS, National Center for Charitable Statistics, I think it is. But basically folks who work on like nonprofit data. And what they would do is they had a small or a handful of research assistants who every month they'd basically go to government websites, see if the agency released new data. If they did, they would download the data, run some checks, generate some summary tables. And then if they didn't, they would ignore that step. But basically they would just like manually once a month just have to go to each of these individual websites. And there are, I think, like half a dozen of them. And then, so basically what we did is we took their existing R code. So there was no need for like new code or anything new that they had to write. We basically just wrapped that in the Python version. So in the RPi2 option 1, in Slade's Lambda functions, instead of having these research assistants and first day of every month or whatever day walk through these steps, there's just a Lambda function that does all of that for them. And then it sends them an email being like, here's your new data files. You can download them from here. Everything worked successfully, or there's an issue with XYZ thing. So again, really just like letting researchers focus on the things that they want to focus on and the things that are a little bit more exciting to them, of which going to a bunch of websites and running or downloading, individual data files might not squarely fall into that camp. So that's one example that I think it just probably resonate with a lot of folks at Urban, especially who maybe just like have a lot of automated data collection that can be automated. So that was one thing that I thought, again, it probably took like 2 hours of time total from both their end to sort of explain what was going on, get the scripts sort of update in the way that they needed to, and then maybe half an hour from me to just like put together the infrastructure and documentation and everything. So very little time to take what was otherwise, half a day's worth from a bunch of different RAs into something that's a little bit more reproducible and a little bit more automatable. So that's one example that I wanted to highlight, and there have been a couple other teams that have been excited about that and tried doing something similar or worked on something similar. And the second one is within a broader body of work around expanding access to confidential data, where we're basically building a system that's meant to provide like an interface between researchers who want to submit, in this case, it'd be R scripts against confidential data without actually having access to that data, and then be able to have noise automatically added based on differential privacy algorithms to those results. So it's just sort of the original use case for this of just I needed to build a system to let researchers upload R code, run that R code from Lambda, and then add noise back to the results and return it to them. So again, in this case, what I think is cool is that Lambda is the fact that Lambda is really scalable here is helpful, and that these algorithms, or the specific algorithm that we're applying here, requires running the code one time for every row in the data set. So if you have a data set with 100,000 rows, you have to run the R code that the user wrote 100,000 times, which can take a little while. For bigger data sets, it can take longer. So the fact that Lambda can automatically scale to run each of those different jobs in parallel really just made it a really great use case here. We're able to take that R code and take that algorithm that otherwise would be really computationally intensive to implement at scale, and then make it run just a lot more cost efficiently than we otherwise would have been able to. So it's a little bit more abstract than I'm saying it aloud of a use case, but those are just two that we have found in the last couple of months since talking a little bit more about this integration. And a little over 4 Eastern time, that's all I have. So I'm happy to put the link to these slides in the chat, which includes the GitHub repository with the demo, along with a blog post that goes over most of what I talked about today and a little bit more of the use cases. And then also includes the two examples that I walked through and a bunch of other links for other ways we've used it. So I'm happy to take any other questions if folks have them.
Yeah, I don't see any so far, but I love those the 2 examples you just gave, because one of the first one seems sort of, I don't know how to say it, but not very computationally intensive. It's sort of just a scheduling thing, sort of busy work, if you would. Whereas the second one does seem to be more. So in other words, the first one, maybe sending it up to the cloud is like, okay, I'm just going to get it off of my computer. I don't have to worry if my computer goes down or, something. Whereas the second one seems more computationally intensive, and where you're actually doing some analysis, I guess, and where, maybe you'd want to do it faster or not taking up all the the space and time on your computer, have it being done somewhere else.
Yeah,
So-
definitely.
Yeah, so the first one, somebody might think, or at least I would think, well, why would I really want to do that in the cloud? Because to me, the cloud is maybe more for the second example. But you make a good point about, well, it may not take a lot of computations, but still it takes time and scheduling, and if you could offload that somewhere, then why not?
Yeah, even just like researchers leave, like you don't have to manage their permissions, things can happen. So the more that you can offload, definitely. Yeah,
Yeah.
also I think is really cool about the second one is that depending on the size of the R script that the user uploads, you can have like 1,000 Lambda functions running at the same time. So if you think about, I don't know, like on your computer, you can only parallelize your code so much. Whereas here, for literally cents, we can have 1,000 different Lambda functions within seconds, immediately spun up. We're able to run that algorithm in parallel. So I'm just like really highlighting that flexibility, that scalability that I think is cool.
That's super interesting. I didn't think about that, but yeah, then you don't have to worry about, well, how many nodes do I have on my my computer or something.
Mhm.
Great, thanks. Somebody has a question in the Q&A. Is the data in your education data portal collected by an AWS Lambda?
That's a good question. The answer is no, but I think the answer is maybe not yet. But yeah, I will say I think a lot of that data tends to be a little bit more, I don't know if like bespoke is the word, but I think it often requires less of downloading an individual file and a little bit more of going to like the NCES website or going to some website and then clicking through a couple links to create the custom download extract that you want, which I see a nod or two. So I think folks are probably familiar with having to click through to get the custom data extract they're looking for. So that's sort of a case where like, yes, I'm sure we could build something to, automate clicking, but at that point is the cost benefit analysis of building, I don't know, some kind of like a Selenium WebDriver to use a headless browser worth the effort of, I don't know, creating that extract yourself. So not right now, but I think there probably are some data sets I think would be good candidates for collecting automatically.
Yeah, actually, it is very tedious and some frustrating to collect data, to try to go to different websites to get data. And sometimes even if it's just your own website. So for example, just trying to go to the census website and get data off of there, I find that I don't really know what I'm doing, and and what do you click on and how do you get it? So yeah, if there were things like this um, to help automate it and make it easier for users to grab it. And I love how you kind of had it where it's just like, I want to do this by this, and and it's kind of like in English, I guess, if you would, or natural language, I should say. So that was great. Oh, another question. It's a data in the portal in a database, and the AWS Lambda function is submitting a query to that database. I'm a bit vague about the division of labor between urban resources and the AWS Lambda.
Yeah, that's a good question. So all of this is running, including Lambda, is considered an urban resource. It's just that instead of it being maybe like a more traditional, like relational database, so something like Postgres or MySQL, or that more traditional long-running database, it uses what we call like a serverless database that's hosted on S3, which is another Amazon service that creates like a storage layer. So that again, that's still an urban resource that's hosted in the cloud with an urban secure cloud computing environment. So what the Lambda function is doing is that the Lambda function is just code to read from that database and then return. Basically read the records from that database, run the computation. So run like compute the average, I don't remember what I pulled up, the average tuition by race ethnicity. So Lambda function is actually doing the computation from by reading from that underlying data structure. So there still is like a database here. It's just in this case, it's a serverless database. So there's a storage layer that's a database, and then Lambda is the compute layer that reads from that database and returns the result back to the user. So all urban resources, Lambda is just the compute layer between those resources.
Okay, that helped me. Yeah, for some reason I was thinking it was, I guess maybe you could do it that way, but I was thinking it was going out, like to the other websites sort of in real time, like grabbing it, and then, but then that's just a different source then, I guess.
Yeah, so in this case, it is doing that. So it is like, it's basically, the way I think of it, it's basically just anything code would do. So here it's just, instead of me running on my computer, go to census.gov, pull in this data set, and then write it to like Dropbox or Google Drive or some other service or to my local computer. It's just Lambda's doing all of that. So it is able to like do all of that. It's just you still need to store the data somewhere, because remember that Lambda function only exists for 15 minutes or however the runtime is. So you still need some kind of a storage layer to like actually put the thing after that 15 minutes is over. Where that can be hosted in the cloud, that can be hosted on some kind of an on-premise server, that can be hosted on your computer, that can be hosted wherever you want, but you still need the storage piece of it in addition to the compute piece of it.
What happens if you run over 15 minutes?
Yeah, it just errors out.
That's interesting. So it's not, so you still have to be careful about your programming and
Yeah, another pattern we see a lot is where for jobs that we know are going to run longer than 15 minutes, to basically write a Lambda function to basically, it's like you write the Lambda function, it only exists for a couple of seconds, and it creates like a different kind of server, or like an EC2 instance, or like a cloud, like a longer running server, and then runs the job on that server. So Lambda function just like creates something that can exist for longer than 15 minutes. And then once that longer than 15 minutes server is finished running, then it just shuts itself down. So you basically use Lambda as like a way to create something, like create like a longer running server. So that's sort of pattern.
to create a virtual machine or something.
Exactly.
Okay, thanks. It's sometimes hard for me to get my head wrapped around these things, but I like how you've explained it. I'm able to kind of picture things and get the framework. Okay, you have another question, if you still have a little bit of time. And let's see, where is the translation between, say, dplyr and SQL occurring?
Yeah, so there isn't, can you say maybe, I'm not sure if, are we allowed to unmute people or I'm a little unknown.
Let me see. Okay, now this, I'm going to be challenged here. Let's see, attendees. So you want me to unmute the person?
I was like, I'm not sure if I totally understand what you mean by translation between dplyr and SQL.
Okay, I just allowed Nabil, if I said the name right, to speak.
Thank you. So I'm assuming the code that I saw, well, or you have this package called Get Education Data, and I assume that package is using dplyr code to decide how to group the data, what statistics to calculate, and so forth. And therefore, at some point, that code has to be translated into the Python or SQL code to process the data.
Yeah, so what happens is it actually uses another serverless AWS service called Athena, which is basically just Amazon's way of saying run SQL, but entirely without having to need a database. We'll put a link to both the here's like the general, I'm actually, I think I sent the previous link to the wrong set of groups, but there's a link to how Athena runs. I can also share a link to how Athena works. I can also share a link to specifically how we're using Athena for the education data portal. But what Athena is basically just a way to run serverless SQL against some kind of a data lake. So it's a data lake hosted on S3, which is an object storage system. But basically that's what the Lambda function is doing, is it's converting that dplyr, or it's converting the API endpoint. So sorry, taking a step back. So the R package converts like the dplyr looking syntax into that URL endpoint. That URL endpoint is then passed along to Lambda that converts the URL into SQL. And then Athena is I feel like I want to like draw this out now, but Athena is the AWS service that runs that SQL against the database. And then once those results are computed by Athena, that's then passed back to Lambda, that's passed back to the user. So sort of like our package is layer one that converts R to a URL. Layer two is Lambda that converts URL to SQL. Athena converts SQL to like the records you're interested in, then Lambda passes that back to the R package.
Got
I
it.
know if that was more or less confusing, yeah.
Wow. That's amazing. So talk about a single point, I mean, the different points of failure. I guess. Different links that where things could go wrong. Wow, that's amazing. All right. Well, good. I'm glad I was able to open up the microphone because that was probably a confusing, I mean, not a confusing question, but like an evolved answer.
Mhm. Yeah, I feel like I never quite know how much to give, like here's the high level version of how things work versus here's the actual nitty gritty of what's going on under the hood. But
Well, and it's probably hard to explain that to what you just did because you don't have a whiteboard to kind of draw things in a flow chart and that type of thing. So,
Mhm.
all right, well, great. Thank you so much. And I really appreciate your fantastic talk and your willingness to come back and give the talk to us. And I have lots of food for thought. So, and I have a task to track down the Lambda R person and see if we can get a talk on that. But anyway, thank you so much, Erica. And again, we really appreciate it and all of your help and information. So I'm sure people will do some great things. Great. Okay. All right. Thank you. Thanks, everybody.
Bye.
All right. Bye.
Hmm.